Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
And Luke, today we have a special guest with us.
Is he really special?
He is for sure special.
So Paul Munford is joining us. He's a new member of our team, and he has a funny accent. So we're going to play a game with our listeners. We're not going to say, but you got to tell us where he's from. So Paul, how you doing today?
Good, thank you. How are you?
Not too shabby. Any guesses where he's from, James? New York?
I was going with Germany.
Germany.
Am I close?
Einfach klasse. Das ist sehr gut. Yeah.
Wow.
Oh, wow.
Okay, now he's showing us up. Okay.
Yeah.
Well, Paul is an expert in all things drawings. 2D, 3D, 4D, history of drawings. Everything drawings, Paul is the man.
Wow, he really built you up there. We got some high expectations, Paul.
Yeah. So if you are interested in this sort of thing, why don't you head over to tolerancing.net? Luke, I'm sure you were there scouring it for information earlier.
I was not.
They have so much information on the history of drawings, engineering drawings, standards, how all of these things works. And I mean, it's all sorts of fun if you're us, but otherwise maybe not.
Net?
Yeah.
Okay.
Who knew that something like that existed?
Wow. Okay.
So Paul, I guess maybe tell us about yourself in 13 seconds or less.
Paul Munford, I work for Autodesk, technical marketing manager. My background is actually, I studied theatre scenery design. So I went to school to be a fine artist, but realized I wasn't going to be a very good painter. So I studied scenery design and worked in film and TV for about 10 years as a carpenter and construction manager and technical drawing. And we did all our technical drawings by hand. And we even did some of them in feet and inches, which blew my head up.
Yeah, well, that's the right way to do it, but that's all right.
And then it was a fun job, but it was difficult to make a living at. So I went to night school and learned a thing called AutoCAD, which I'd never heard of, but I had to buy a computer to use it, and became a draftsman and spent the next 15 years learning 2D CAD, 3D CAD, working my way up to CAD manager, before eventually working for a reseller, and then finally getting to come and work with Luke at Autodesk.
That must have really just been a highlight in your life, huh?
Working with me?
Working with Luke. Yeah, that's what people just aspire to in life.
Gracious. So, interesting side note.
Oh, boy.
That I don't even think Paul realizes. Nick Offerman, the famous American TV actor from Parks and Recreation. You know, Nick Offerman, the guy with the big mustache.
The mustache, yep.
Ron Swanson.
There we go.
He, too, was a theater carpenter, painter, stage manager, and went into acting. Maybe Paul's next step is going to be into acting. What do you think?
I don't think he can get any worse.
So was Harrison Ford, and they are doing a younger Han Solo, so maybe I could go for that.
I think you might need a little more hair for that one. Sorry, Paul.
Missed the boat on that one. All right, so let's get started here. So for all of you listening that have actually stuck with us for the first 3 minutes, let's call the first third of this show the history. So if you don't care about history, why don't you just skip to about the 10-minute mark, and then you can listen to all the cool stuff about drafting and CAD and where things are going in the future. How's that sound?
Sounds perfect.
All right, so getting started, I guess we have to go with cave drawings. What do you think?
I think so.
Or cave paintings, I suppose they are.
Well, if you look back, that's probably the first, I'd say, time people were actually documenting stuff. They were taking like charred pieces of stick and drawing on
maybe
cave
berries,
walls.
I don't know.
Yeah, whatever it happens to be. My
I
guess.
think the oldest reference I found was 500,000 years ago.
Half a million?
Yeah, some etchings on a shell, but it was the first sort of mark making they could say was deliberately made by human beings. And I think that's absolutely fascinating, because that means it wouldn't have been Homo sapiens. It wouldn't have been the same species as us. That would have been Neanderthal. So this is like something inherent.
Yeah, that's craziness. The oldest reference I saw was 40,000 years ago in some European caves, particularly in Spain, as well as on some Indonesian island. And
that's it. So
try and say it.
So how much time has gone past? Like the most of the 500,000 years has gone past, and nobody's done anything other than doodle, like make some marks, like go, oh, that's really fascinating. I can make a mark, but it doesn't mean anything to me. I'm just scratching and having fun.
And look at what we did from like, like the 2000s until now. I mean, it's like they were the worst back then. Why did it take them so long?
We're way better at inventing.
So much better.
And communicating.
Well, part of that was Neanderthals. They didn't seem to do much in the way of innovation. It took Homo sapiens to come along and kind of escalate things.
Yeah. So the 40,000 years ago thing is about when people were deliberately drawing and trying to communicate something with that.
Deliberately mark making. And I think that's the fascinating and interesting thing about drawing is it's something unique to, as far as we know, humans, because we're not just making marks for the sake of it, or we're not building like birds building nests just for a purely practical thing. We're trying to imagine the future, and we're trying to say, I could imagine the future to be different. And we're doing a drawing to sort of describe our vision of the future. And then we fit the world into that. And that's what engineering is. So that's fascinating that way back then, people were saying, I want tomorrow to be different today. So let me do a drawing of what I imagine tomorrow to be. It's extraordinary.
Oh my!
He's really deep.
So I feel so dumb now compared to Paul. Thank you very much.
Paul, you live on that side of the pond somewhere, Germany or something like that.
That's it, yeah.
Istanbul we're going with now. Have you seen these old cave paintings?
No, there's none in England as far as I'm aware. They're in Germany, I think the ones you're referring to.
Oh, okay. Yeah. Well, maybe.
There are some very famous ones in the UK, but they're so often blocked off now because they get destroyed by people visiting them.
Maybe you could take a train over there and check them out sometime and report back to us.
I could do a 3D laser scan of them. Yeah,
that would be cool. All right, so moving on. The first type of drawing that I'd consider more like on topic for us would be perspective drawing techniques, invented during the Renaissance period, right? Back in the 1300s. And this should be right up your alley. Don't you know all this art stuff?
Yeah, absolutely. yeah. But we can go back a little bit further.
Wow.
So the Greeks were doing things called projection. So if we think back as to one of the reasons why people would have wanted to document or draw, it was probably a lot to do with the seasons and the sun and the moon and the planets, right? Because we know that they were interested in that, because we have things like Stonehenge. So we have an interest in the seasons and trying to predict when the seasons are going to change. So it follows that one of the earliest things they were trying to document were the stars and the star maps. Now, way back with the Greeks knew that the Earth went round the sun, and they knew that the Earth span on its axis. They even knew that the Earth was on a slight axial tilt from the rest of the ecliptic, from the rest of the orbit. So they knew all this stuff. They worked it out way before the Renaissance. In fact, the Renaissance was when we rediscovered all that work.
Obviously, Paul, you haven't listened to our flat Earth episode because the Earth is flat. Sorry, Greeks.
Yeah.
You'll have that.
So if you can imagine taking a light source like a candle and shining it on somebody, and then having that silhouette projected onto a wall and draw around it, you've just created a projection. You've just created a drawing. So, so I think it probably came from way back then.
Yeah, but is that? I guess that is drawing. I mean, they're documenting something. I guess the essence of drawing is you're documenting something. I guess I'm being a little too nerdy. Paul's being very existential. I'm thinking I need to draw a carburetor kind of thing.
If we're counting scratchings on a shell, then I feel like that has to count, right?
Okay, yeah.
But here's the fascinating thing, Lou. Right? You've got a kid, haven't you?
Yeah.
How about you, James?
No.
Oh, you have all that joy to come.
No.
It's fascinating. You've just seen this. If you have a small child, you'll have realized that quite early on, they'll recognize the concept of like a cow, right? But this is what's fascinating to me. You have a cow in a field and it's big and smelly and it's, goes murr. And yet they can look at a little fluffy plush toy and know that's a cow also. They can look at a drawing, that's also a cow. You can say moo, cows don't go moo, but they recognize that's also a cow, right? So we make that logical leap that took like 500,000 years to get to. We make it in the first year of our life. We pack all that in, just get it now. So you can say, I need to draw a carburetor, but you're forgetting just how much work you've already done to get there.
Yeah.
Did you say cows don't go moo? Is that what you said?
Obviously, he doesn't know cows.
It's not.
I don't know if he's an expert anymore.
I mean, the drawings, just not in cows. Okay, well, fair enough. All right, so we're going to just bust through this stuff. How about that?
Sounds
Perspective drawings during the Renaissance. Two key features about this. Objects are smaller as their distance from the observer increases. Sound about right?
That's right. Yep.
And object dimensions along the line of sight are shorter than the dimensions along the line of sight, which I suppose makes sense.
Yeah.
So I guess that's all I had to say about that.
So imagine what I said earlier with taking like a candle and shining a light on something and it projecting onto a flat surface. Take the candle away and put your eye there, and that's a perspective. Yep. So that's your perspective drawing.
I think the interesting thing about perspective, and the reason why I can't wait till you say the guy's name, the French mathematician, I can't wait. The challenge was, before we came up with uniform or standardized drawing practices, everybody's idea of perspective was different. There's single point perspective, there's 2-point perspective, there's ways to just draw things and not even really use perspective. So up until I'm going to say it was somewhere, when was it? 1765. Up until 1765, you could literally, have two different people in two different countries draw the exact same thing and be totally different. There was no scale, there was no, reference to work from, and that was creating tons and tons of challenges. And then I can't wait till you say the guy's name. James always does our pronunciations.
Well, before that, fun fact, our good friend Leonardo da Vinci was likely aware of multi-view drawings, they say.
You think?
But he never used them, only perspective sketches. And they say that might be because of his background in the arts. What do you think, Paul?
Yeah, that makes sense. I mean, technical drawing, the way we describe it now with all these flat planes, is completely unnatural. Like if you took a kid and asked them to draw, they tend to draw things all in one plane, but just like one on top of the other. And as they get older, they start to realize things are in front and behind each other, but it's not perspective. What's really interesting is you can point out perspective to like an 8-year-old and they'll pick it up really quick. So it's sort of fascinating, again, how the amount of time it's taken humanity to get here can be compressed into a human lifetime, and we can pick it up very quickly and get all these techniques. But yeah, sure, it's much more natural to draw kind of just how things sit in front of you.
He's obviously never seen my daughter's drawings.
I bet they're awesome.
They're straight up engineering drawings. All right. So before moving on to 1765, let's take a break for shout outs this week.
Oh, I love shout outs. My guess is
it's actually a word from our sponsor.
Oh,
our sponsor this week is our good friend JP. How did he become a sponsor? Jason, we actually met him in Las Vegas last year. Money? He provided us with a box full of Canadian snacks.
What's a Canadian snack?
So they're potato chips that come in a box.
Oh, they're unusual flavors,
don't make sense to me. Well, I guess in Canada they're normal.
Okay.
One's ketchup flavored. One's,
I like ketchup on it.
Well, we're gonna test them later.
Okay.
One's an onion and garlic flavor. There's another hickory smoked stick. There's a candy bar and some other candy in there. So we're going to do a little live video of us taste testing these. That will be on
James, did you send me a box?
I'll consider it, but probably not. Maybe I'll save you some for...
I'll just pretend. We can cut that bit out. I'll just go, These Moose chips are delicious.
They look great. Ketchup chips. So we'll see if Canada knows how to do things right. So thank you, JP, for that. Yeah. Also, anyone who wants to send us stuff, please feel free to do so, because I love free stuff.
Yes.
And if you want to get a shout out, email us at unprofessionalengineering@gmail.com.
Subscribe to
the podcast. Give us a review, which would be awesome. And if you want, we will send you some amazing Unprofessional Engineering stickers.
They're really good.
They really are. So that's probably it for our sponsor this week.
Perfect.
All right. Moving back up.
On.
So you're just really excited about this 1776.
Yeah, because I think, so this is really, and I know we got to go kind of quickly through this. I know this is really where it all started, like 2D drawing, like our concept of what 2D drawings are today. So what I learned at school, I don't think you learned.
I did learn it. Just not
you did
much.
2D drawing at school?
In high school, I did.
Okay. I know Paul did. I know I did. But this is
you know what? Ironically, I was encouraged not to take technical drawing at school.
Really?
It was considered a subject for children who were not very academic. So I was encouraged to take things like languages instead, and I was terrible at them.
I feel like that was a shot at us right there.
A little bit, but that's all right.
Cool. Yeah. That hurt. All right. So the father of descriptive geometry, what you're talking about, all these things that we learned, Gaspard Monod is what I'm going with. Mon?
I don't know.
How would you say Monge?
It could be Monage or Monage, because it's French, so it'd be
Let's go with Menage. How about that?
Nicki Minaj.
There we go.
Gaspard Menage.
So he developed this technique in 1765 while working as a draftsman for the military on military fortifications and later publishing his findings.
Yeah, so he was formalizing work that had been done by a mathematician called Albrecht Dürer, who's a German guy. So he was really the first one who documented a lot of this stuff. But it was because it was military, it was actually kept secret.
Yeah, he wasn't allowed to talk about his research for a couple of years, right?
No, that's right. And then eventually, it was actually so well established that it became taught in all the French schools and the French universities. And at that point, it became in the public domain and everybody else got hold of it as well. So ironically, he was also one of the first people to encourage the teaching of technical drawing in colleges, which would have been one of the first steps to formalizing what a technical drawing was.
They just wouldn't encourage you to take that because that's beneath you.
I took it till I was about 16. I just wasn't allowed to take it after that.
Okay, well, that's fair.
So for those that are listening that don't understand what we're talking about, this is basically orthographic projection. So we talked about perspective. I think everybody kind of remembers drawing perspective. You put a point on the paper, you draw lines that kind of represent the vanishing point of something. Sometimes you have two vanishing points in two different sides. But what orthographic projection is whenever you basically pretend you have this 3D object, whatever you're making, and you're looking directly at one side. So you're looking only at the front, only at the right, only at the top, and you draw just that view. So you basically ignore what you see on top, ignore what you see on the side. So it's a way to, very simply and easily take whatever it is and document it and capture all that detail for that one particular view. So
yeah, it's completely unnatural. Nobody would ever draw that in real life. You actually have to learn to read these things. So it's like another language. But it's an interesting quote in that book I was just telling you about later. You can put it in the show notes. We think in the languages that we know. Drawing informs the way we think. So once you've learned to do technical drawing, you start to think in terms of technical drawing, and you can describe and communicate in ways that you couldn't before.
All right. I guess that brings me to me not talking anymore, because we're going to be talking about engineering drawing standards, the future of where drawings are going.
Yeah.
And kind of like how draftsmen work and then transformed into AutoCAD and 3D CAD.
Yeah. So basically what starts to happen, obviously, we standardize on this orthographic projection, this means of documenting what we want to create in 2D. And that basically started right around, I'm going to say 1770, somewhere in that, neighborhood. Yeah. And what happens is over this period, obviously, there's different standards created. We in the US are using the correct, English standards. There's ISO standards. What do you guys use over in the UK?
We use ISO standards, but we have our own BS flavor of them, British standard flavor of them, where we don't accept everything if we don't like it.
Okay. Okay. And basically what happens is all of the things that I learned whenever I first went to school for 2D drafting was kind of like the culmination of that. So this is actually, thinking in 2D or drawing in 2D when you're thinking in 3D. And this is where all those different cool tools come in. So you're using T-squares and you're using protractors and you're using straight edges, you're using compasses and all those different really cool hands-on tools. I got a bunch. I'm sure you probably have all your stuff from school as well, Paul, right?
Yeah. You forgot eraser shields.
Yes.
The most handy thing in your toolbox, yeah.
For erasing, right?
For making corrections, yeah.
Oh, very interesting. I don't think I ever got past like the T-square and the triangles. And a compass, I guess.
So
that was it.
I'm a firm believer that before you learn how to do something on a computer, because it's so easy to make mistakes on a computer.
You're aging yourself here.
Well, I'm sorry.
Or dating yourself.
But I think when you learn on a board and you learn to draw, to Paul's point, you don't want to have to make corrections if you don't have to, because it's really laborsome to make those corrections, especially if you're like the end of a drawing. So when you learn how to do things drawing by hand in 2D, I think you're really deliberate about what you do, and you end up making better drawings with AutoCAD and with 3D applications nowadays. I've definitely seen that difference. People will they'll draw all day long and then just erase it or change it, and it's just like, I would never consider doing that. Like, I would really think about what I'm going to do, really be specific, then draw it, and then you're done.
I think you've got something there. I think what was interesting for me working for an Autodesk reseller and training people was it was much easier to train a machinist or a maker, somebody who made stuff, in how to use 3D CAD.
Yeah.
But basically make a computer simulation of the thing they'd like to make and use that as their communication tool, than it was to teach people who'd learned technical drawing and who'd done 2D, because they had to give up all their 2D CAD knowledge to be able to do 3D CAD. Mm-hmm. So I think you've got something. I think it is important, I think, again, for young people to not jump straight onto computers and conceptualize stuff using a pencil, because we can all have a pencil handy all the time. It's just an extension of your finger. One of my college tutors used to say, when you give people directions, you say you go along here and down there and you go up this street, and you're drawing with your finger. So just put a pencil in it, you can make a drawing. So I think it's great for people to have the confidence to draw, but I don't think it's a necessary step to learning 3D CAD. I don't think
it is. I think it helps.
Yeah, I think it can potentially be a little bit of a barrier to give up some of their drawings. Where it really helps is in creating a drawing of your 3D model.
Yeah.
And I did find people who'd never had to create a drawing by hand, never had to compose a drawing on a sheet, would do terrible drawings because they never had to think, how do I get from this view to this view? Mm-hmm. What information should be on this view? How do I tell people which other drawings they should be reading with this drawing? So how do I bind this whole thing up into one package of information, which is easy to digest?
So we're going to do a big fast forward here, just in the, what's the word I'm looking for? Just in the interest of time.
I was going to say, I'm kind of lost on all this. I don't know.
All right. That's drawings. All right. So we're going to jump right to the inception of CAD.
Can we take a break first?
We can.
And talk about Luke's rant for this week?
Yeah, I don't think it's going to be Luke's rant. Isn't it going to be?
It is in fact going to be James' rant this week.
Oh, is this a good one?
Okay? I don't know.
You didn't tell me ahead of time.
I think you'll appreciate it.
Let's hear it.
So I'm going to mention that we got our first 2-star review on iTunes. And that hurts a little bit, so maybe I'm a little too close to home on this.
Who is it?
I don't know, some guy. And it's not that we got a 2-star review. That's cool. If you don't like us, go say we're doing a bad job. That's fine. But he was nice enough to say that he likes the hosts. He thinks we're funny. It sounds good. Blah, blah,
What's
blah.
The problem?
But that it basically wasn't enough information, and he found things that were wrong with it. And before you go yelling, I just want you all to consider that the name of this is Unprofessional Engineering.
Yes.
If you're here to learn how to build an engine in 30 minutes, you're probably in the wrong spot.
Yeah.
If you're trying to become a mechanical engineer, go to college. Don't listen to us.
Absolutely not.
So I do appreciate that you gave us a review and took the time to tell everyone that you don't like us, but do like us. But really, how much do you expect us to be helping you out here, writing your thesis or something?
Yeah,
I mean, we do get paid a lot of money to do this, but still.
It is unprofessional engineering, to go back to that. And I feel like if we called this professional engineering, James,
oh my goodness,
I would totally expect him to say what he said.
Well, then we'd need Paul on all the time. We wouldn't be able to do this.
Yeah.
You make me feel like I've already taken this far too seriously.
So that's that. I do appreciate him reviewing us, though, because it did give us our 40th review, and we still have a 5-star on there, so that works.
Okay.
So go us. But that was my rant. Just remember the name.
But how do you do 2-star and say all those good things?
Maybe he was just a nice guy and was being generous. He's like, actually, it's really terrible.
Okay.
So go ahead. Let's talk about the CADs.
Yeah, so I don't mean to jump forward too much, because there's a whole bunch of stuff there in the middle.
This could be multiple episodes, right?
And maybe we'll do that. But what I want to make sure we cover is we get to the point where I'm going to say most of our listeners, because, we're pretty popular with a young, hip crowd. They don't know what a 2D drawing is, or a T-square, or a protractor.
Protractors.
So we have to start in 1957.
Wow.
Which I'm sure they know about. And this was basically the inception of CAD. And there's some debate on this one about which one happened first. I have this really sweet timeline. Hopefully we can share it. But there was this guy by the name of Dr. Patrick Hanratty, worst name ever. Sorry, Patrick. And he's basically considered the father of CAD. And he created a program called Pronto. This was basically one of the first commercial CAD applications that actually had a user interface, and you could actually, see what you were drawing as you were doing things. Soon after, this was the one that most of the research I did found was Sketchpad, which is weird because it's kind of a weird name.
Yeah.
Ivan Sutherland. This one was a total graphical interface. You actually used a light pen. It was a touch-sensitive screen. You drew on the screen. So this was back in 1960. So there's some debate as to which one is truly the first CAD application. I think Sketchpad was the first 100% graphical user interface, because Pronto, there was a little bit of programming that was happening and it wasn't 100%. So there's a little bit of debate on that one. And then I'm not going to go through this entire timeline. This is actually a pretty intense timeline. But what was happening with these CAD applications, and Paul, you're a little bit older than I am, I think.
Just a touch.
Just
wow.
a touch.
Maybe a year or two.
The size of these machines you needed and the cost. Any thoughts on the size of these CAD machines and how much they cost?
Oh, they were like $50,000, weren't they? I mean, people used to work in shifts. Yeah, they used to sit at a terminal and do your 8-hour shift, and they'd have people working 8 hours at night as well because the machines were so expensive.
Yeah.
Wow.
And the other thing too is a lot of these machines and the programs themselves, they were super proprietary. So this would be like, for example, McDonnell Douglas, who makes, aircraft and aircraft components and engines. They had their own specific CAD application that their own internal IT department created, and they built specific computers. So basically from, 1960 all the way up until roughly, I'm going to say it's right about 75, whenever CV started. Computer vision was one of the first, publicly available. You could go buy computer vision. Most of these between the 60s and the 70s, these were proprietary CAD applications, enormous machines, like as big as this room kind of machines. Took up tons and tons of computing power, and it was crazy. All they were doing was just 2D drawings. They weren't doing anything super high end, no renderings, no simulations, no 3D, none of that stuff. So, and where it all really starts, and I don't mean to be, to skip over too much of it, but where this really starts is, I think, when we think of 2D is, and if you have other stuff there, Paul, 1982. So the first commercial CAD application that ran on a PC, not a mainframe, was AutoCAD. There was a handful of other ones. They weren't necessarily commercially available, but this actually brought CAD, or 2D AutoCAD, to the masses. So individuals who had PCs could actually run this. You didn't need a mainframe, and to Paul's point, I didn't need to sign up for a shift to use a computer, or I didn't need to use punch cards. So so 1982 was AutoCAD. Any other stuff before that or right around the AutoCAD time frame, Paul?
Well, I was just thinking again, in terms of perspective, that's like 500,000 years of human history to get from scratching on seashells to the first ever computer program that can do this. And then from 1957 to like the mid-1980s, we've got like a 20-year period where now anybody can sit down at a computer and do technical drawings. So the fascinating thing about that is that hand drafting is a bit of an art. There's still a bit of talent required. There's a set of rules, anybody can learn it. But when you sit down at a computer, almost anybody can draw at a computer because you just type in commands and the computer does the work for you. So we're now making it much easier for anybody to get into this profession and start creating professional looking drawings, which is, again, really sort of interesting and fascinating aspect of it.
So the next big thing I think that happened, so there was a number of 2D applications out there. So you have Bentley, you have computer vision, there was just lots and lots of different 2D applications. But I think the next big step that happened, this is kind of crazy. I didn't realize how long, publicly available, commercially purchasable 3D CAD softwares out there. But in 1987, so this is literally only a few years after the first 2D application with AutoCAD, PTC came out with Pro Engineer, and this was the first mainstream CAD program that actually could make 3D models and generate 2D drawings. The crazy thing was all of these proprietary programs that Ford created, and McDonnell Douglas and all these different big automotive and aerospace companies built, they kind of fluffed off and kind of brushed off PTC, and the reason was it wasn't super stable, it wasn't super robust. But I think what they failed to realize was the fact that this would run on a PC, it dramatically reduced your investment. The mainframes and the software around that time to be able to do 3D CAD were hundreds of thousands of dollars. So it wasn't like you'd had to buy like a $4,000 or $5,000 PC. It was hundreds and hundreds of thousands of dollars. I'm pretty sure the McDonnell Douglas program was somewhere in the neighborhood of $500,000.
Wow,
which is crazy to run CAD. So then the next thing that happened, we're getting short on time. So we're going to blast through this now, and then we'll save a couple minutes for kind of where we think it's going to go in the future. And Paul, I'd love to get your input on the future stuff. So 1993, SolidWorks comes in and they say, hey, we can do 3D even better and cheaper and faster. SolidWorks soon becomes amazingly popular. Autodesk jumps back in the game.
SolidWorks developed by John Hirschtick.
Yeah.
John Hirschtick got his money from
Blackjack.
Have you ever seen that film about the MIT maths and science geeks who were going out to Las Vegas and card
That was him?
Yeah.
That was him.
Part of that crew.
No.
Yeah. I think that's probably the most interesting fact about CAD is that that's how SolidWorks started. It's amazing.
Blackjack?
Yeah.
How did I miss that?
The Counting Cards movie?
Yeah.
Go check it out. We'll look it up after
I saw
this.
it. I didn't realize that was him. Okay. Okay. So SolidWorks hits it in 1993. Autodesk jumps into the game with Mechanical Desktop, which was basically AutoCAD on steroids. So it was an AutoCAD-based 3D application. They get into the game again in 1999 with Inventor. And right now, there's basically three players in CAD. It's SolidWorks, it's Autodesk with AutoCAD and Inventor, and PTC, and that's kind of where we are up until, I'm going to say, 4 or 5 years ago, and then the game changes quite a bit. And I'm going to leave it to you, Paul, to talk a little bit about some of the cloud-based stuff, and we'll give our opinions on where we think this stuff is going in the future. So
so after that sort of 500,000 years of human history, we've got a very short period in which CAD gets democratized and put on everybody's desktop. So we can now all use 2D, 3D CAD. So what's the next big thing? You kind of it's accelerating this fast. Where are we going to go next? So I think Cloud CAD is where we are now. So the two main competitors here are Fusion 360 from Autodesk, and John Hirschtick went back to college and he took a new degree so that he could come up with his own CAD-based system, Onshape, to remember it there. So we have these, and I think what's fascinating about these is the sort of key aspect that's tying all this together is the fact that we can now communicate so much faster and so much quicker. And that's what's accelerated this growth in technology and ideas that's taken us from this very patchy development of people putting ideas together and then people forgetting stuff and then different people in different countries picking it up to very rapidly developing new ideas very quickly. So I think the future of technical drawing is going to be probably not flat 2D black and white sheets of paper. So I think it's going to be 3D, it's going to be full color, it's going to be embedded 3D models spinning around inside documents. But I think there's still a need to be able to communicate and track information and know who has what information at what time. So I think there's still a need for people to be able to pass off packets of information. And I think we'll continue to call those drawings, even if they don't represent those flat sheets of wood pulp anymore.
Yeah. So real quick, I wanted to get all of our thoughts on this cloud CAD thing, right? So it's been a mainframe, it's been a PC for really, really long time. And this cloud CAD has been around for a few years now. There's like you said, there's a couple folks doing it, Fusion, Onshape. Do you really think it's going to catch on? I'm going to say yes, because the price, and yes, because of the access that you can have. So Paul had mentioned, like, you could do this anywhere. Like, I could be on my iPad potentially, or on my phone, like looking at things and maybe adding some notes. So I do think it's going to catch on, but I think it's going to be a really long time before people are willing to get rid of their PCs.
I don't think they necessarily will get rid of their PCs, but I think one of the other big problems they have to tackle is IP issues. Once people are more comfortable with that, I think moving to the cloud will be a much smaller hurdle for them. Maybe just a little bit stronger PC performance as well. Internet connections and being browser based will probably be where they move to.
Okay.
So in effect, we've taken a slightly retrograde step, right? Because we had one big server, one massive machine, and everybody logged into the same machine, but they were hugely expensive. But the advantage was all the files were on the same machine, so anybody could log in and work on the same data. And then we've gone distributed to PCs, which is great because it's cheap and everybody can have like all the power they need at the point they're going to use it. But we've had a huge headache around files and file sharing and collaboration and where's my stuff? Where's today's stuff? Where's the new stuff? If you've ever been on a project where they said, I want all the latest drawings, and you think, you've got them, but they don't trust the system, right? They don't trust they've got the correct data. So working over the internet allows us to be able to pool our resources much better and collaborate better. But you're quite right. The issue around that becomes then, where does the data end up? Who's got it? Like, who else has access to this? How secure is that? So I can see that Cloud CAD has caught on for students, for small businesses that just need to get hold of a CAD system, for companies that need CAD as a peripheral, kind of graphic design, 3D design, industrial design. They're all using it right now. But none of those people have major IP issues. I think for companies that have major IP in-house, they don't want it on the cloud. So they're going to keep, particularly people like the military, they're like 10 years behind everybody else anyway.
Oh, yeah.
They're going to keep it local. They're going to keep working on it local till they can be absolutely convinced that they have the security measures in place that will stop their knowledge getting leaked.
All right. So I think with that, it's about time to call it a day.
Yeah. Felt a little rushed, but maybe we'll come back and touch on a couple of these other topics.
There are a lot of things that we could dive into. We could probably have 3 or 4 episodes out of all of this, but not today.
Yeah.
All right. Well, Paul, thanks for joining us. You shed even more light onto our very brief overcap of drawings.
Yeah.
Thanks for letting me bang on about